All right, class, let's continue our discussion in 2.4, putting derivatives to good use. So, the second derivative test for extremes. What does that mean? The thing is, sometimes when we solve a problem, we don't want to graph and see and go through the first derivative sign diagram, second derivative sign diagram, just to see if we have a minimum or a maximum. We are already solving a long word problem, and we just want to know, is this a min or is this a maximum? How could we tell quickly? Okay, without having to draw the whole picture or, plugging in endpoints and so on and so on. So, there it is. It's pretty simple. Let me draw two pictures for you. What does a minimum look like? Well, there you go. There's a minimum value, yes? What do we know? We know that the derivative is equal to 0, right? We have a horizontal tangent line, so it looks pretty. But so at this point C, let's say, at this point C, the derivative is equal to 0. So it was one of our critical numbers. Now, how do I know if I just take the derivative, find my critical numbers, how do I know if that critical number is a minimum or a maximum? Well, that's a minimum, clearly, yes? What is happening to the graph around it? As you see, it sits down in a hole. If you're really looking at this picture, what can you tell me about the second derivative? What's a smiley face? Yeah, so if you have a minimum, the graph has to be turning up like this. So clearly we know that the second derivative at C must equal to a positive, right? We have a smiley face. So this is all we're going to have to do. So I'll recap in a minute. I just want to show you the other situation. What if we have a maximum at this point C? Well, what I know at the point C, first of all, how did I even know to look at it? Because I knew that the derivative was equal to 0, right? So we had a critical point. So look, I have two critical points. How do I know which one's a min and which one's a maximum? Well, for a maximum, what has to happen? The graph has to be turned upside down, yes, to reach that peak value. So what happens to the second derivative? It's a sad face, yes, to reach that peak value. It has to make a sad face. So the second derivative has to be a negative. So this is the second derivative test for extremes. Find all the critical points of f, or really the critical numbers, yes? So how do I look? And again, I'm not thinking about the undefined ones because those are a little bit iffy, but they're nice rounded up. So what I'm saying is, look, right? There is really, it doesn't sit in a ditch, and yet it's a minimum value, but it's also that the derivative was undefined there. So I'm looking at these nice rounded ones, okay, where the derivative is equal to 0, yes? So for those points where the derivative is equal to 0, where you have a nice smooth graph, either for a min or a maximum, all you have to do, find the second derivative, add it. If the second derivative is less than 0, in other words, negative, yes, then the graph is concave down, so you have to have a maximum, yes? So if the second derivative is negative, then you have a maximum at that value where the, again, first derivative was 0. If the second derivative is positive, right, more than 0 means a positive, then the graph is concave up, right, and you have a minimum, okay? And if it's 0, then maybe a min or a max or neither. Really, it's just going to be neither for these nice ones, because how could you have the second derivative also equaling to 0? I'll show you a picture right here. So here's a point C. What happens at C? There's a horizontal tangent line, yes? So the first derivative is 0. What else happens at C, at this point C? Well, it's an inflection point. Why? Because the graph has turned from looking down to looking up. So what happens? The second derivative is also 0, right? So it really turned into neither a min nor a max. It's one of those points like the cubic function creates, right? Okay, all right. So we're going to put this to good use in word problems, as I said, so we don't have to draw a whole picture just to see, is it a min or a maximum? So here's your favorite. a bunch of word problems. Okay? All right, the first one's super easy. It says, and the reason why the first one's super easy is because we are given the function already. Okay. So it says, the fuel economy in miles per gallon of a certain car is given by this function, where x is the driving speed in between 20 and 60 miles per hour. So x is the speed, and I should have written it in miles per hour. And f of x is the amount of gallons used, or I should say fuel economy. And it's measured in miles per gallon. So basically it's telling you if you're driving at 20 miles an hour, you can, on your car, you can get 35 miles before you use up a whole gallon, right? So that's what that is. So it says, at what speed is fuel economy greatest? So basically what we have to do is find the maximum. Okay, so this one's easy. In fact, it actually goes in with the first part of this section, but let's see, how do I find a maximum or a minimum? Well, I'm going to first have to find those critical numbers, yes? So find the derivative. So what's the derivative of this function? It's going to be negative 0.015 times 2 is negative 0.03x plus 1.16, okay? So how do we find the critical numbers? We set this equal to 0, right, and solve it. So that's easy. I'm just going to say that. Add the 0.03x over to the other side, divide by 0.03. So put that in your calculator, and I had an answer somewhere. Well, I don't have it anymore. So I'm just going to have to use a calculator. I don't know where I put that paper. So, really quick, 0.16 divided by 0.03, it's about 38.67, okay, miles per gallon. Okay, so what have we learned? That if you want to find a min or a max on a closed interval between two values, not forever, all I have to do is make myself a table of values with what? The beginning, the end, and any critical number that fits in between. And 38.67 does fit in between. Okay, so put this into your function. And oh Jesus, what have I done with that paper? I threw it away. Oh well. So I'm not sure what these y values are. I don't really want to go through it. I'm just going to pause this really quick.